Hello everybody, this is Henri Batouflet. I'm a support engineer at IXBlue. Welcome to this last session of our series of video on how to prepare your INS DVL integration. In this last session, I'll speak about extra tips and features, things that I didn't told you or told you very lightly during the previous series of videos. For the first tip, I will speak about the mechanical integration. So one of the things I didn't really mention is also to make sure of those extra connectors that they are very fully watertight. For example, I have this connector here that is missing an O-ring. So I will service it before your eyes. So you see it's very simple and takes a few seconds to service them. So I'll just remove all the parts one by one, put them on the bench. I will have to apply this new O-ring here. I use the specialist tool that is provided in the box with the unit. I take a new O-ring from a plastic bag. If the new O-ring comes from somewhere else, it's probably void. So I'd rather use it. Now I prepare my tool by pushing it a little bit like this, and I fit it to the connector I want to service. Here it's a dummy plug, but it could be a big cable or any other part of your equipment. I will gently press it until it clicks and then turn it a little bit. Of course, I put beforehand grease on that O-ring. Now I just have to fit it back together and my connector will be watertight again. Once I did it, I can have a visual check on all the connectors and all the O-rings before I would go and see. And you see I fit it back to the unit, so now my unit is watertight. The second thing I did not mention so much is about the mechanical alignment pins. I strongly recommend to use them for both the DVL and the Rovins, so that you know your kit and you know your mechanical parameters towards the use of another unit or during or after maintenance. For the second tip, I will speak to you about the full Ethernet interfacing. One of the other methods to link this INS to this DVL together would be on a full Ethernet configuration. This will happen mostly when you want to use inside an AUV or somewhere that is network compatible. The full Ethernet configuration will make things more simple, but you also have to prepare for an Ethernet strategy on the IP address ranges. Either you keep the one of the DVL or the one of the INS, and you can change them in each other's user interface. All the rest of the configuration will be about the same, so this will be the same settings you will have to apply and the same steps you will have to follow towards the INS DVL calibration. Further testings of the DVL. So we've seen that because we are in the workshop today, it was very difficult to get the DVL data into the INS and to see more like on the algorithm status. You will have some solutions to test further your DVL. One solution would be to reconfigure it towards an ASCII protocol so that you can visually see the ASCII protocol coming through the external sensor control panel. That would be a good indication there is no crosstalks on your line or other artifacts that may impact the communication of the DVL to the INS. The other thing you could do to test it would be to put it in a small bucket of water. That bucket of water would have to be big enough so that there is valid telegram of the DVL. We do it sometimes here at IXBlue, and I know some of you out there have some bigger water tanks, so you can test that kind of integrations while in your workshop. Otherwise, you would have to wait to be at sea, and when you first go underwater, start the DVL, start it pinging, see the DVL telegram coming up through the INS interface, and make sure they are received and valid from the status panel. External sensors and their impact. It's something I did mention very lightly through the previous presentations, but the way you choose and define your external sensor will have a great impact on the results and especially the outstanding performance you could achieve with this INS DVL kit. One of the things that is most important is a good positioning accuracy sensor. Position sensor, while on the surface or for the surface calibration solution, I will recommend the use of RTK grade GPS. The RTK grade GPS over the differential grade GPS will give you a few benefits. You'll have shorter calibration line, you'll have a faster time to converge the heading standard deviation. That very same heading standard deviation that will impact a lot on the results and the performance you could get of an INS with the DVL coupling. The second thing would be to consider for the GPS while on the surface or for a depth sensor while subsea in terms of altitude value, the Z value of the INS, the inertial computation. This Z value will be very important towards the pitch calibration value of this INS DVL. We've spoke a little bit less about the pitch calibration value, but basically the same way I have an angle and a scale factor error on my calibration line, I will have a tiny pitch error. This pitch is mostly induced by the mechanical integration aspects, but will also be measured the way you travel with your vehicle. Having a good Z value sensor will greatly improve the calibration results and the calibration performance. I encourage you, when you go subsea, to choose the depth sensor mode for the altitude computation, and while you're on the surface, the GPS computation mode for the altitude solution. The last thing is about the SVP. The sound velocity probe will compensate the speed of sound, the celerity, the salinity, the temperature, and the depth of this DVL sensor. It will have a good impact on your ability to estimate the scale factor error of your DVL in regards of your INS. Having this sensor interface to your kit will greatly improve your performance. The idea is to say it will reduce the scale factor error to truly the sensor scale factor error, the DVL scale factor error. It's not actually an error, but it's a difference of method of measurements that we want to estimate. That's the reason why we do the calibration, so that basically both units speaks the same language. Optimizing the DVL calibration. There's a few things we can do to optimize further the DVL calibration procedure. I'd like to show you 3 of them. The first one would be the speed of this calibration procedure. I strongly encourage you to go around 5 to 6 nodes, constant speed on your calibration line. This will allow you to measure a better scale factor from the INS computation. The second thing you would have to do, and that I recommend, is what we called in our line of work the perfect alignment. So go a little bit more on the 8 shape pattern or the square shape pattern for your heading standard deviation to converge even below the marker values we provide you. For example, the Rovins Nano, you can reach 0.1 degree second of latitude heading standard deviation quite easily after 10 minutes eventually. I would encourage you to go maybe at 0.07, 0.06 if you continue only 5-6 more minutes. It will very much impact the INS computations we do inside the Rovins, and so the heading accuracy we have inside, and so our measurement of the heading error in your INS DVL calibration. The last thing you can do to improve your DVL calibration would be to continue your calibration line further. We give you some visual markers and also documented in our technical documentations. That's when it will change from orange to blue. We say the calibration value is stable. Nothing prevents you to continue your calibration line a little bit further, like again a few hundred meters to narrow even better the estimates of the heading misalignment and the standard and the scale factor misalignment. The more you go, the better accurate it will be. And so if you can continue on your calibration line and operations allow you, I would strongly advise for it. I'd like to finish by thanking you for watching those series of videos. We took a great pleasure of making them. We surely hope they are useful for you. Feel free to get back to us and give us your feedback. You can always reach us at support, AXBlue support 24/7, support@axblue.com. Thank you for watching.